Right, so in this video, we're going to look at a Hungarian algorithm minimizing problem. So in this, we are looking to generally try and find the best allocation of people to roles or similar things so that our total amount of time, cost, or whatever is at a minimum. So the question here, we've got a cleaning company with 4 employees who are Arnold, Barney, Clayton, and Darren. They're assigned to clean a house. The matrix shows the time that each employee takes to do the jobs, which are clean the appliances, clean the bathroom, clean the dishes, and dusting. And an example is that if Arnold is doing the dusting, it's going to take him 4 hours. We want to do the optimal allocation of people to jobs to get all of the jobs done in the least amount of time. If we look at the full algorithm, we're going to start off with that information written in matrix form. So that is taking it out of that table and making it a bit more less contextual. Effectively, if we look here, we've just got the numbers there. Then we're going to take the minimum value from each row from every element in that row. Then we go to the columns. We take the minimum value in each column from everything in that column. Then we move on to our next steps, which get a little bit more complex in the way that they're written, but in reality, they're actually not as difficult as they might seem. So let's start out. We've got our matrix here. We can see that our first part of the algorithm is subtracting the minimum value from each row from everything in that row. So if we look at our first row, our minimum value is 2. So we're going to take 2 away from everything there. Second is 1. Third is also 1. And fourth is 2. So now we have 5 take 2, 2 take 2, etc. Eight, 2, 1, 0, 0, 2, 4, 6. So that is our first step. Our second step is to do the same, but we're looking at the columns. So if we look at our first column, we can see that 0 is actually our minimum. So we're not going to have to do anything there. Second one, we've also got 0 as the minimum, so we're not going to do anything there. Third one, we have 1, so we're going to subtract 1 from everything in that column. And then our third one is also 0, so we don't have to touch that. So we start writing in our columns that we didn't have to change, just so that we have those there ready to go. 2606. So our third column is going to change to 1 take 1, 7 take 1, 1 take 1, and 4 take 1. Now, the thing that we need to do here is to try and cover up our zeros with the minimum amount of lines possible. And we need to do that to determine whether or not we can come up with a solution from this point in. So what we want to do when we're covering up our zeros with these lines, we want to cover as many zeros as possible at once because we're looking for the minimum amount of lines that can cover these zeros. So if we look at the columns, we can see that this one has 2 zeros. This one also has 2. We look at the rows, this one has 2. This one has 2. When we're doing this with a bigger example, you wouldn't want to cover up the row that's just got 1 0 in it because that's probably not going to give us the minimum number of lines required. So let's start off. We've got 2 zeros here, so I'll cover that up. We've got 2 zeros here, so we'll cover that up. And our last 2 zeros I can also cover up with 1 line. Now, if we look at our algorithm, cover the zeros of the matrix using the minimum number of horizontal and vertical lines. If this minimum number of lines is equal to the number of rows in the matrix, we can skip step 4. However, we've only got 3 lines, and that is definitely the minimum that we could do. So we need to actually do step 4, which is to find the minimum uncovered number in the matrix. We subtract that value from each of the uncovered numbers, and then we add this value to numbers that are covered by 2 lines. So let's have a look at this one. We have got, out of our uncovered numbers, 5, 6, 6, 2, 3, and 6, 2 is our minimum number. So what we are going to do is we are going to add that to the 2 numbers that are covered by 2 lines. So that is going to give us 5 and 10. Everything that's covered by only 1 line does not change. And what you might notice is that means that most of our zeros get retained. So we don't lose those zeros, which would make things a bit harder for us to find a solution later on. Then we're going to subtract this 2 from everything that is not covered by anything. So that's going to give us 3, 4, 4, 0, 1, and 4. Now, once again, we are going to try and cover up our zeros with the minimum number of vertical and horizontal lines. Again, if you look at our little example here, there's 2 in that row, 2 in that row, 2 in that row, 2 in that column, 2 in that column, 2 in that column. So we're just going to start by knocking out any of those that we feel like first. So let's just go with this one here. The zeros remaining, we've got 2 in this one again, so let's do that. We've got 2 that we can get here, and then we've still got 1 left. Now I could draw that as a vertical or a horizontal line. Does not make a difference. The main thing is that we're just identifying that we needed that to cover up all of our zeros. What we do from this point here is that we can acknowledge that we do have a solution that's possible. Now we are going to try and choose that solution. So by doing that, we're going to click or select the zeros so that we have a 0 that goes in each row and column, but does not contain any double ups. So this one here on this row is definitely going to be the only thing that person B can do because they have not got anything else going on there. So we select that one. That means that person D cannot do that job because it's already been done. So we look at what person D can do. They can do this job here, so let's circle that. But person A is not going to be able to do that job now. Person A can only do this job, which means that person C can't do it. And then person C can only do this job here. If we have a close look, we can see that this is a logical solution because we don't have anyone doing the same job and we don't have 2 jobs allocated to 1 person. So what we do with this shape here is we transpose or we put that on top of our original matrix. So in our top left, we can take that over there and say that we've got this one here, this one here, this one here, and this one here. Looking at our original matrix, we've got Arnold, Barney, Clayton, and Darren, and they are doing appliances, bathroom, cleaning dishes, and dusting. So we're going to superimpose that onto this just so that we can make it extremely clear. Now, in your answer, you are going to say that Barney is allocated to appliances, Darren is allocated to the bathroom, Arnold is allocated to cleaning dishes, and Clayton is allocated to dusting. That would be how you answer that minimizing question. That contains all of the bits that you need to do in order to gain all of the marks possible. Now, if we got to this point here in this 4th matrix that we drew, and we still didn't have 4 lines that covered all of our zeros, we basically just repeat what we did to get from the 3rd one to that 4th one. We would still look at all of the uncovered values, find the minimum, we add that to anything covered twice, we don't touch anything that's covered once, and then we subtract it from anything that is fully uncovered.